So a lot of us gearheads grew up messing with internal combustion, be it gasoline or diesel. We spent years, even our entire careers, making this stuff quicker. But the days of internal combustion are numbered. Electrics are coming, like it or not. But you know what? You gotta be open-minded. If you've ever been in an electric vehicle, especially a performance one, there's something about that instantaneous throttle response, instantaneous maximum torque, and really good top-end power. Now, a lot of us grew up doing hybrid swaps, you know, like putting a B motor in a Honda, putting an LS in a S13 or something. Well, you know what? There's a new swap game in town. AEM has come out with a new division, AEM EV, and their specialty is making the electric swap in your regular car easy, without a whole bunch of engineering, with stuff you could just buy. Now we have this Mustang behind me, and it has a hybrid Tesla swap. So you get all the power of a Tesla in this lightweight Mustang. This car is badass, let me tell you.
So easy.
And we're gonna put it up on the rack, see what makes it tick, and we're gonna go on the test drive. You guys with me? Let's go. All right, so we got the old test tang here up on the lift, and Lawson from AEM is gonna walk us through and answer a bunch of our questions, which I have because, man, I hardly recognize any of this stuff under here.
It's kind of like a mullet, man. The party's in the back.
So that more looks like a kegger back there.
But way more fun. So this is the motor you'd find in a 2013 to 2015 Model S.
And these are common in junkyards?
Yeah. This is the LS swap of the electric world. So our controls, we're able to control a lot of different motors. This is our newest release. So we can control all of the inverters that Cascadia Motion does. If you're unfamiliar with Cascadia Motion, check them out. They make amazing electronic motors and inverter systems. But obviously for the Tesla, what we do is you've got the motor and the inverter. The great thing about the Tesla is its packaging. You know, one of our engineers, Nate Stewart, says the unitization of it, and I think that's the perfect term. It's unitized. You've got the inverter and the motor packaged together. You've got your half shafts. Everything is designed and built into this subframe assembly. So this car was originally built by an EV enthusiast in the area, and he had done this conversion. We were looking for a sport drive unit for development, which, if you're wondering, we're almost done. So the base drive is out now. The sport drive is coming. The small drive will be next.
Can you explain the difference between the base drive and the sport drive?
Okay, so like in LS, right? You've got your 5.3, your 6.0, then you got your big one with the blower on it. Very similar kind of thing if you think of a Tesla drive. So the very first motor in a Model S was this one.
Okay.
And this is the base drive, large drive unit. So then when you got the P cars or the performance editions, those ones got the sport drive, which is physically the same externally, but it's a higher capacity, higher output motor assembly.
And those are still pretty common and reasonably priced.
Yeah, there's lots. In fact, they're really desirable in the EV segment because they make more power. And prior to us coming in and giving you the ability to do torque mapping and kind of integrate your system and make it all inclusive, you were sort of stuck with like a piggyback or whatever kind of electronics you could get to sort of trick the computer to think it was still in a Tesla and run. So you were limited by that. So everybody wanted the Sport because it made more power. What's really cool is with the battery combination that we have along with our torque mapping and what we've done on the performance side, we can actually outperform a Sport motor with this car, with the base drive. And we've shown
how much does one of those typically cost in the junkyard?
It really depends on condition and what style you get, but you're looking at, I've seen prices anywhere from like $4,500 up to $9 or $10,000 depending.
So it's like buying an LS3 out of a vet, about the exact same price.
It's about the same. The difference is though, once you have it in, if it's a good motor and inverter setup, you don't have to maintain them anymore. They'll run
They never wear
virtually
out.
forever. Yeah.
You don't have to go through them before you drop them in.
No. In fact, we could take in 5 or 10 years this entire propulsion setup out of this car and put it in something else, and it'll still run. Might want to upgrade the batteries in 10 years.
And I guess what people don't realize, they go, well, that's kind of expensive, but it's the same as getting the LS, and you don't need the transmission.
Exactly. This is a direct drive that you just noted, so there's no additional. You can run it in direct drive, but I don't know why you'd want to. And Tesla also gives you like a 9.5 gear reduction, so when you factor in the torque going through that, you're getting gobs and gobs of power right at the hit. It's so much fun. Well, you'll see when we go for a spin.
Well, what else do you need out of the Tesla when you buy the whole?
So what the gentleman who originally designed this, what he was able to do was retain, because of the unitization or the packaging of the drive unit from Tesla, a little bit of notching over here in the side, and then put these big heavy wall brackets in with the cross braces to accept the entire subframe from the Tesla. So this whole thing just snicks in. We had to get some special wheels. Obviously the Tesla's wider than the Mustang, so we had to get some special offset wheels to push back in. These wheels are actually off of a Corvette, 2008 Corvette, with some Ford center caps, and we've got some custom wheels on the way from FinSpeed that we're looking forward to getting on that'll fit really, really nice, and they'll be gorgeous. But in the meantime, these get her done. They give a little bit of poke, so you got a little bit of extrusion on the outside, but it's just got the right look to it for us. But that's it. This is it. This is the motor inverter assembly on this Tesla subframe. If you look on the outside, it's still running Tesla half shafts. It's got the solid discs and the Tesla calipers.
So actually, it's a killer deal because you're getting a modern multi-link suspension. You have the heavy-duty axles, hubs, everything you need.
Yeah.
So it's way more than just getting an LS motor. It's getting like everything you need.
Kind of getting all the good stuff. Yeah, in fairness, we took the Tesla suspension, or I should say the gentleman that designed it took it out. It's complicated. It's like a magnetic ride suspension thing. And we wanted a little bit of adjustability too. So it's got a set of QA1 coilovers, which actually mount up if you look. Other than the custom bracketry on the bottom, they mount very, very cleanly.
I mean, this is all like really basic, simple fabrication, and it's easier than making motor and tranny mounts almost.
You just hit on the exact thing that makes me so excited about this, because here's the reality is I know there's some guys watching, they're like, EVs suck. They don't suck, I promise you. Drive one. It's a game changer. What's cool about our community and the enthusiasts is I see our guys, once they start to embrace this, really taking it to the next level because of the level of fabrication skills, the level of innovation and ingenuity that we see from the enthusiast community at large. There's a lot of great EV shops out there that are making really nice EV examples, but we're performance guys and we always want to push the envelope. So what's really cool about this is we're going to see more and more performance examples from guys that have traditionally done internal combustion engine. And I can tell you, we're already getting a lot of inquiries from shops, from our regular internal combustion engine shops, because they've got customers coming in asking, like, hey, I'm considering electric. Do you do something like that? The best part about it is our industry guys already have the chops to do all this. It's just learning the new wiring and learning some new software. And we've even taken steps to make sure that transition's really easy by changing the way that you would normally program an electric vehicle, through the CAN bus and literally writing lines and lines of code to a really common, something you'd see like in our Infinity software, graphs, tables, charts, something that's very easy to navigate. And it also helps you kind of make that jump from the internal combustion side to the electric side from a setup and a programming standpoint, because of the way it's configured. It's easier to program, and you also you're able to see those similarities. In fact, I wish Sam Chaseving, one of our tech specialists, he is one of the best guys I know at being able to take the analogies of the internal combustion engine side and make it relatable on the EV side. And we're doing some of that on our website too, in our FAQ section.
Okay. So you got this thing here.
Yeah.
Well,
So this is our contactor box. So you're seeing the not pretty side. When we bring it down, you'll see that's got all of our contactors, which are just big giant relays that engage and disengage the high voltage system. And those are all basically controlled by our PDU-8, which is our power distribution unit. It's an 8-channel. We make modular PDUs, so you'll find one up front controlling some switched functions and then the one in the back, all of which is programmed through the VCU. So if you're asking, like, why do we do this? In the conversion space, there was really no comprehensive solution for controls. You had some open source, you got piggyback software, you have some things that do a little bit, but nothing that really did everything. And so we saw an opportunity to give you all the control that you want to really take the car from sort of a hobby to something that you can drive every day.
so the contactors are, they're like giant relays,
Yes.
but they require pretty sophisticated electronic control, so you
Yes.
don't fry the contacts, I suppose,
Absolutely.
right?
Oh yeah. Just the ability to go through the processes. What you just mentioned is, again, and not surprised because you're always thinking kind of on the higher tech level, but yeah, that's our software. That's what our guys have been developing. Just the very process of engaging or disengaging the system requires a series of checks that the computer needs to go through to make sure that it's safe. And that's integrated into our VCU.
All right, so now I guess we're gonna go, there's a whole bunch of cool stuff down that way.
Yeah, let's walk up the front and then we'll kind of come back and we'll put her down and we'll look topside. How's that sound?
All right. All right, Lawson, there's a bunch of fancy stuff under here. What does it all do?
Nah, it's not too fancy. Okay, so what we have going on up here, you see these are some battery packs. So when we drop this down, we've got one set of batteries. We have a battery pack under the hood, and then we've taken a second set because we no longer have a transmission or drive line or a gas tank. We were able to double our battery capacity by breaking out these and moving them down the tunnel. So this gives us about 36 kilowatt hours. These are hybrid electric batteries. Without getting into too much detail, they're fantastic for performance. They love to push current, much more so than like a Tesla battery. Tesla batteries push current great, but they like to derate. They've got a job to do, and they do their job very well. They last a long time, they give you great range, and they give you great performance, but we're all performance, and we're not as concerned with range and that sort of thing. So these batteries are ideal for getting as much power out of the motor as possible. In fact, we were able to make a little more power than the Sport Drive, which is the next iteration up of the large drive unit, utilizing these hybrid electric batteries.
So they're all low in the chassis too, so that's going to help your handling.
Doesn't hurt the cause. No, not at all. And then some of the other things we've had to do is obviously we don't have a giant pump to drive accessories with now, so everything had to be electrified. We've got an electric brake booster here. We retained the pump from a Tesla
For the
cooling.
loop.
Yeah, and again, like some of the cool stuff about conversions, especially like sort of the later classic, modern classic stuff, is you've got really good low voltage systems to work with already. You've probably got pretty good cooling systems and stuff. You know, our system is just a single loop cooling system. That means that it is cooling the inverter and the motor. We retain the factory radiator. We utilize the Tesla pump, and then the guys just made a really simple loop. You can see it coming out here, down these hard lines, back into the drive unit. Comes out of the other side of the drive unit back in, and that's our loop. Very simple. We can also, if we lived in cold weather climates, do a heating loop and a cooling loop. And we can do dual cooling loops if we so choose. So if we ever seal these batteries off and we want to actually add a cooling loop or a heating and a cooling loop, we'd be able to do that independently, one for the drive system and one for the batteries.
Now, since there's nothing to power the power steering, how do you do power steering?
Electric power steering, actually. You'll see it when we bring it down.
Okay.
We have an electric power steering pump that's like a Ford, Mazda, Volvo. It's a great piece and works great.
And where do you get these batteries from?
Those are sourced from, well, they came with the car, honestly. And batteries are one of those things where we strongly recommend, like, you can get a drive unit off of eBay, but like anything you buy off eBay, you know, caveat emptor, right? Let the buyer beware. Know who you're buying from, know their quality. We work with some great shops, Electric GT, EV West, Stealth EV. There's some quality shops out there that have resources to good components. Buy from somebody. If you're going to buy your drive unit or you're going to look into your batteries, look into sourcing them from reputable places that'll have a warranty, that if they're selling you a drive unit, they've inspected it, they'll put a warranty behind it, and you know that the batteries are coming from a good source.
And so you have your batteries, cooling loop, vehicle accessories that are all handled electrically. And I see these fancy looking AEM boxes.
Yes, sir.
On the side of every battery pack.
Right.
You probably want to talk about those, right?
I do. This is our battery management system.
Okay.
So what that does is exactly the way it sounds. It monitors every individual cell in the battery system, and then it reports all of those values back to the VCU so it knows what to do with it. Why does that matter? Well, temperature, discharge, current state of charge, all of those things. And again, because temperature plays a really important role, each one of our modules has 3 thermistors. So we call it the BMS 18 cell taps with 3 temp sensors built into each one. There's a master, and then you daisy chain satellites to the master, and then the master sends all that data back. Again, modular, because while we've got 6 sets in this pack underneath the hood that you'll see, and we've got 6 units right on top. Here we've got 2, so we had to put the BMSs up under here. Got 2 more here, BMS is here. So now you can see where having the modularity makes sense. If we didn't have these small units, we'd have to put one giant BMS somewhere, and then you'd have to be running a ton of loom. This just makes it much more elegant, a lot easier to install, and you can get a lot more creative with how you package your vehicle.
And these batteries are air-cooled, right?
These are air-cooled, yeah, and which is fine out here. We're in Southern California. It's great. We get a good cross breeze. We've drag raced the car, road raced it last weekend, or I should say autocrossed it. It's gotten tons of street time, and it's pretty good. But we also have conditions in the VCU programming that if we start to exceed temperatures, it'll derate the battery to protect it. This is something that you can have your cake and eat it too, right? You got your hot rod, you can drive it daily. This is actually street legal. This is registered in California as an electric vehicle with the DMV. It took us about 30 minutes, really easy process. But we can go out and hit, mid to high 11 second quarter miles on these tires. So we could probably, take some weight out of it and put better tires on it and go quicker. And it's pretty competitive, turning a wheel, and we haven't even really begun to set it up. So that's the idea behind this. Is
with drag radials, you'll be running 10s.
Exactly, right?
And with slicks, you'll be deep into the 10s easily.
Yeah. I'm anxious to find out. So I want to get some drag radials and check that out and get some stickier tires for autocrossing. And then there's some suspension things that we want to do. So again, this is a rolling test bed, but it's also a perfect example of what you can do with this technology. And so we've created the list of all the high voltage components that we use to develop this vehicle, and it's a pick list. I mean, you could literally take that list and this configuration and put it into practically any vehicle.
Well, I'm looking at the fabrication and the wiring, and I mean, it's really not that hard.
It's screaming our audience, right? Like, our guys can do this.
I mean, to do an LS swap in the S chassis, for instance, like they sell all the parts to, do a bolt in. But the first S chassis swaps, they weren't that hard either, but you had to make your own stuff. And this really doesn't seem any harder than that.
No, and think about it this way. Like you said, you got S chassis swaps with LSs. Then all of a sudden you have shops that begin to specialize in that, and they have some custom bracketry and some things. And I see this going much the same way.
Yeah, they'll have kits. So
you're going to start seeing it. Yeah, I mean, I saw one of our specialists. This was a couple years ago before we had even, finished long before we finished development on the Tesla base drive controls. But he's an Evo specialist. I saw him do a Tesla swap into an Evo. So You're seeing that. You're already starting to see it.
So we got to talk to the guys at Hasport to do a
That's right.
swap kit for a Honda.
There we go. That's right. Let's get a drive unit into a Honda.
Okay, so are we going to go up top now? And
Yeah, let's bring it down, and we'll show you the under the hood, and and then let's take a look. We've got a little peekaboo, and we'll show you the contactor box and sort of how the high voltage stuff comes together in the back.
all right, Lawson. Here we are under the hood. There's a bunch of nuclear reactor looking things.
Yeah, no more 3-valve.
Yeah. You want to tell us what's going on here?
Yeah. So obviously the 4.6 is gone now, as is the transmission, the drive shaft, the gas tank, and all of the emissions components were removed. As you saw, we had to replace the mechanically driven accessories underneath. That also includes the power steering pump. So now all power steering is managed by this electric pump. This is a pretty common unit out of a Ford, Mazda, Volvo family. Works really great and just plums right in.
Now this is the more batteries and
More
the battery.
That's right, more cowbell. So you saw the other half of the battery energy down below, where we had taken essentially this pack and broken them out and then spread them around underneath the vehicle, a couple up against where the trans was, where the drive shaft used to be, and then back where the gas tank used to be. So the other pack we have all up under the hood behind the axle. So it's great weight, not only low distribution on that half, but this one being behind the axle. And then we have our battery management system with a master and 5 satellites. All of this data, along with all of the data from the BMS that are attached to the packs underneath the car, go back and are reported in the VCU 200 in that corner. So the VCU 200 manages all of the programming for all the conditional stuff in the battery management system. So not only do you do your torque mapping, all of your safety stuff, we'll have traction soon, so you'll be able to do traction control, multiple performance levels, pretty much program the car. You also program the BMS, and right below you right there, that's our PDU-8. So it's a power distribution unit, 8, which means 8 channels. Like the BMS, these are modular. You can daisy chain multiples together. We have one up here. We also have one in the back. So that provides power to the pumps, power steering pump, the cooling pump, the brake booster. It also powers up the DC to DC inverter. This is out of a Chevy Volt. It's a good unit. And a couple other accessories. So what it does is it gives you 8 switched function controls that you program through. And again, we could do a 32 channel, but now you got a big box, you got to put it somewhere, and you got to run a ton of wire wherever you need to go. The beauty of this is it's solid state. You don't have a giant relay box with a bunch of redundant wiring. It goes in very cleanly, and it all goes out to the VCU over CAN bus.
That's the main fuse right there? And these are your main cutoffs?
Yes, those are your main cutoffs. So those will break the packs in the middle.
And that runs the 12-volt system of the car, right?
Absolutely. So think of the DC to DC as sort of like your alternator on a nice car. So that steps down your high voltage energy and powers your low voltage system. So it basically feeds the 12-volt battery that then independently powers all of your normal accessories.
And what are these circuit breakers for?
These are for the PDUs.
Oh, okay.
Yeah.
And is there anything else you want to?
No, I mean, that's the nuts and bolts of it. One of the things I'll comment on that, I said before is, again, the great thing about the later classics is that you've already got a pretty robust 12-volt system to start with. So if you retain that and then you just power it through your electrical system, you're mostly there. Then it's just a matter of getting your belt-driven components electrified, and you're ready to go.
And stock radiator.
Stock radiator, yeah. This is still the Ford radiator that we're using for the cooling loop. And if we wanted to, we could seal off all of our batteries and run a single cooling loop through everything. I'm not a big fan of that, just because of the way the engineers describe. Obviously, batteries and motor inverters run at way different temperatures. So what's great is you can do independent cooling loops with our VCU. And you can even do, if you're in cold, or if you live in a climate where it gets really, really cold and really hot, you can do independent heating and cooling loops for both the motor inverter combo and your battery packs.
You know, like, after you explain it, it's really not all that bad.
It's not. That's what I mean. Like, here you are thinking it's Mike, you guys could do this in your sleep. I've seen what you built.
Not knowing anything about electrical cars, though, it was intimidating when you first opened the hood, though. And, I mean, it's actually pretty straightforward.
It's very straightforward. I'm telling you, it's a ton of fun. I'm so excited to get you in to do some seat time. So let's go take a look in the back. Let me show you the contactor box and some of what we have going on back there. Let's get in and go for a run.
All right.
All right.
All right, Lawson.
Okay.
So let's see what's underneath this magic carpet here.
It gets a lot more exciting under the carpet. So in the very back, you can see the top side of the Tesla drive unit and get a little better shot of the cradle from the subassembly. The orange loom is for all of the high voltage cabling. That's pretty much industry standard. And then obviously we got a lot going on in this box. This is what we call the contactor box. So your high voltage system requires big giant relays to engage and to disengage. This is your contactors. So your fuses and contactors in this box are all being powered through another PDU-8. You can see in there. So like we had one up front, we have another one in the back. If we had more switched control that we needed, we could add yet another one and then do all the programming again through the VCU. And then the PDU is also powering up our level 1 charger. We got a real simple charger on here. It came with it. We'll be upgrading this. I believe we're waiting to finalize some stuff on fast charging, and then we'll be doing some upgrade for some testing. So this is really, as you were saying earlier, this comprises the system. While if you're new to it, it can seem pretty intricate. But again, this package with all of this stuff, you could essentially put into any vehicle, and with our controls, have something you could go track with and drive it every day.
So the contactor needs to kind of have some buffering so you don't like fry the contacts, right?
Exactly. Yeah, and that's what the PDU does. The PDU activates the contactor, wakes it up, and then triggers it.
So what's this circuit board?
That is called an IMD, or installation monitoring device. We really strongly encourage that you install one of these on any EV conversion. Basically what it does is it monitors the insulation resistance between the high voltage and the low voltage systems. If there's any kind of short in any way in any of the electrical system, it alerts the VCU. So it's a major safety type thing that can really save your life.
Is it because this thing's a floating ground? And
yeah.
Oh, okay.
Yeah, that's the way the cars are designed. So, you ready to take this thing for a drive?
Hell yeah. Let's go humping some stuff.
Come on, man. Let's go light them up.
All right. All right, Lawson, how do you fire it up?
All right, super simple procedure. First thing you're gonna do is key on. So go ahead and pop the key in the ignition and just turn it to the on position. There you go, okay. Now keep your foot off the brake and you're gonna hit the lightning bolt. That's going to engage the high voltage system and activate the contactors. That's turned green, which means that our high voltage system is engaged. So now, go ahead and close your door, put your foot on the brake, and hit your drive mode. But before we do that, let's go ahead and talk about some of the controls. This keypad is CAN based. It is also programmed through the VCU. So you're probably picking up on the theme that the VCU oversees and supervises everything in the car, as well as all the programming features that you can do. So you can run direct and indirect drives, like the Cobra Jet 1400, the drag car that runs our VCU 300, a couple of our dashes, multiple PDUs, and our CAN keypad. Just a little different button configuration. Obviously that car shifts, so it's a little different. Uses one of our boost solenoids to activate the automatic shifts, which is kind of neat. But I digress. So what we have here is, if you press the turtle in the hair and watch the screen, you're at performance level 1 with a 450 Newton meter torque target. We actually do a little better than that on the dyno. I think we did 460. Now go ahead and press it again. Now you're on 2. It's reduced to 400. Press it again. You're down to 350. Press it one more time. You're down to a torque limit of 300. What I'm showing you really is just that you have the ability to program in multiple torque maps and change them on the fly. which is great. So as you know, this is your conversion car, and you've got a high output motor, but maybe your kid wants to take his date. You can dial down the power. You can set a valet mode. Racing, you can set a pit mode. You can also set different performance levels for different tractive forces on the track. So there's a lot of flexibility to be able to make adjustments on the fly from a performance mode standpoint.
That's traction control?
Yeah, we haven't finished it yet. But when we have it, you'll be able to integrate that and it'll just work. Like, you've used our stuff, so you know our software is free. When we make improvements, when we add features, we update that and we make that free to our customers. The same thing on the VCU side. So AEM Cal is what we call the EV software for the VCUs. And once we have completed the validation of the traction control, you'll be able to do speed-based traction control. The aux is exactly that, like the PDU. The control switch devices, we're just giving you a switched button here that you can control directly from the VCU. So you can program this to control a switch.
Okay.
And that's the nuts and bolts of it, really. At this point, you just put your foot on the brake, select reverse, and we'll back out and go for a drive. But before we do that, let's go ahead and put it back on all the beans. So press it one more time, and let's get back to performance mode 1. There we go.
Full beans. Let's
all
go.
the beans. Let's do it.
So get the old golf cart deluxe out.
A lot of people think of these that way, and honestly, when we got it, it was kind of that way. It didn't have the manners that you're going to experience now in terms of drivability, and it's not that it wasn't a great conversion. It was just what was available at the time versus what we're able to do.
Has a nice smooth idle.
Yeah, you're going to find, I don't know when the last time you drove an S197 is, but you're going to be really surprised with how balanced this car is. So let's go ahead and do a little street and head us toward the freeway, and let's take a little bit of a loop.
Now that's way better than...
Better than expected?
Yeah.
So you're at performance level 1, which has a 450 Newton meter target. On the dyno, we overshoot that a little. So it's putting out in torque about 340 pounds-foot of torque.
Oh, okay.
That's going through a gear reduction with a ratio of 9.7 to 1, so nearly a 10-time gear reduction. So it'll give you the beans.
Yeah, that's the instantaneous power is pretty nice, and the really nice throttle response.
Yeah, and that's really what makes them so fun. You've got you have that instant torque, and it can be a really good time, but the management of that torque is what makes it fun. So that's the difference between it being, like you said, like a golf cart, you know, or an RC car, full-size RC car, versus something that's drivable.
You know what's good is, you know, like how traffic's kind of shitty right now?
Yeah.
And kind of got to squirt around to make a space. Well, the throttle response is so good that I can cut all these suckers off. Really
Confidence inspiring, right? You don't think twice about pulling out in front of somebody because you know you're going to gap them.
So I have a GT3 Porsche, and that car is like the quickest throttle response, and you know, one of the fastest responding engines that, you know, I've experienced, and this thing kicks its ass in response. All my other cars are turbo cars, and you know, you got to wind them up a little.
Yeah, there we go. Go for it.
So easy.
It's really easy, right? And bam, just like that, we're going 55.
No, we're going more like
55.
I think we hit about 90
55.
and 55 really quick.
It'll get up and scoot for sure. It's a lot of fun.
You know, the thing is, it's deceiving. Like, you know, it's kind of like a GTR. You don't really think you're going fast when you are, just because the power delivery is so smooth and seamless.
Yeah, well, and that's the custom torque mapping. So that's the time that the guys spent, you know, not only characterizing the engine, but then mapping in the torque, and then getting the drive unit into the vehicle, and then doing, you know, spending more time fine-tuning it for this chassis. The great thing is, once we've characterized it and we put an initial torque map on it, it's like ice tuning, right? When you have a base calibration, you have something to start with. Makes it a lot easier. So going forward, I can see us definitely providing, as we get into more and more motors, once we know we can control the inverter and we know we have the common motors that those inverters control, we can start to do better characterization, provide better, for lack of a better term, base calibrations or base maps for torque maps. So it's wide open right now, and there's a lot of opportunity. The cool thing about the Tesla swap, what we've done with the controls for this is we're giving you that. We're giving you the communications cable, the inverter control board, the VCU, and all of the base calibrations. So you can take this system, put it in practically anything, and it's going to work.
What I like about this is, other electrics I've driven, they kind of like, you hit it, you get this big torque swell, and then they kind of just seem to, it flattens out, but this thing has a climbing power curve.
That's the batteries.
So it feels more natural, like more like what you would expect.
Right. So you've been in Teslas. Teslas are amazing vehicles. The Plaid, I haven't driven one. I've seen them run at the track. They're blisteringly fast. But every Tesla that I have driven and the stuff that we've had in and all our guys, you'll notice it gives you that amazing torque hit, but it drops off very quickly. So, at 6,000 or so RPM, the torque, that current drop off really, really kind of pulls the guts out of you. You quit feeling that pull. The batteries that we utilize in this car, they can push that current out further. So that's what you're feeling, is because we're able to carry that current further, we're able to carry the maximum torque further out. And then when it drops off, we have more torque under the curve. So you're actually just getting a better sensation of acceleration all the way up until it winds itself out.
Yeah, I really like that feel because, you get the torque hit and the throttle response that you expect in an electric, but you have like the climbing power curve, like you get with an IC car, and the kind of linearness of the throttle. Instead of that then it's kind of like nothing, and you gotta fish for it.
Yeah, well, that's the other kind of neat thing about EVs. I mean, they deliver power differently. So you get a lot more torque, you get less power off the hit, but then obviously as your torque drops off, that power band, your horsepower will actually, with a good battery, stay really, really flat. So you don't get quite as severe of a drop off in terms of horsepower on the top end.
Yeah, look how we could just zigzag through traffic like that. With these.
It's effortless, right?
Yeah.
How's it feel to you?
I really like it. For instance, like it's a lot more responsive than my Evo, and my Evo is a very low lag, really responsive turbo motor.
Dude, I love the Evo, and I have a feeling you just heard some Evo owner feelings, and I love that car. So that's a heck of a compliment.
So it's more responsive than that by a lot, and the Evo has a little bit more top end.
Yeah.
And like it pulls a little harder on top, but my Evo makes almost 500 horsepower. So, it would be interesting to see what a race this will do in the Evo. I'm pretty sure this would get it out of the hole. And
we're going to drag race them?
Evo's not at the shop right now, though. That's the only thing.
It's okay. We'll let's go get a track.
Yeah, we should try that.
You want to? We do 8th miles down in Irwindale. Just go down fun runs on Thursday.
Yeah, this thing I think will kick the Evo's ass in the 8th.
I know. We need a little more space. Maybe we'll once you get this guy cut in, maybe we need to do a day at Famoso.
It'd be interesting to get this thing and have it take on some people with tuned cars.
Mm-hmm. Yeah. Well, we know where it'll sit. This car runs pretty consistent high 11.7s to 11.8, right around 117 to 119 miles an hour, and it's deadly accurate. These cars are going to be make bracket racing very, very interesting because they're so consistent. It's really going to come down to driver and reaction time. It's going to make it interesting. So I'm excited to see how bracket racing unfolds with the advent of the electric vehicle and hot rods like this, right?
This thing is so good for cut and thrust, crappy LA traffic. I mean, it's the ultimate.
Right? And think about it. You can take it to the track. You can drive it every day. This is why we're so excited about it. Think of all the cool cars out there with not so great engines in them.
Yeah, I'd rock this as a daily, no problem.
No problem, right?
I mean, I think I'd rather have this. All you need to do is get the AC to work, Lawson, and I want one as a daily.
So the gauges the dials are in. The gentleman that purchased it, I think he removed it because on a typical EV conversion, there's no way to do AC well. Or there wasn't, I should say, until we came along. So he removed the air conditioning because there was no good way to run it. With our system, you can actually run a real air conditioning system. Temperature dependent. It actually pumps in air and matches it versus cycling on and off hot and cold air. Matt Hauber from Stealth EV did the EV development for the Icon Derelict, which is a 42 Mark II, gorgeous car. And we had not released our stuff at the time, so he doesn't have our VCU controlling the propulsion system, but he installed the VCU purely to run the air conditioning in the car and also to run dual independent cooling and heating loops because it's an Arizona car. It sees everything from high 115, 117 degrees down to the 40s and 30s in the wintertime. So the gentleman wants to drive it all the time. He needs to be able to manage both the low and high end temperatures of the batteries and the inverter of the motor. So that's all run off of our VCU. So short version is you can do AC when I got it in. Hopefully it'll be summertime. We'll put stickier tires on. I'll bring it back and we can roll in the cool air.
I mean, there is like absolutely zero annoying characteristics about this powertrain. And space. Somehow it was so ingrained that I'm heading this way.
It's okay. We got plenty of battery, man. Let's drive. Let's go fast.
I mean, shoot, this is like. I mean, there is absolutely. I mean, shoot, I would daily drive this thing in a heartbeat.
I love noise. I mean, I love the sound of a well-tuned engine. With proper harmonics, we've got the right intake note and the right exhaust note, and it makes that sound, right? But the cool thing about driving around in this is it's so stealthy. I mean, how many times have you womped on it, and unless you're really paying attention, you don't really know.
The cops won't know either.
That's what I was alluding to.
Oops. I mean, this is super impressive.
Mike, I'm excited with your response because I know what a dyed-in-the-wool petrol head you are. I mean, we all are, right? Those are our roots. I've said it before. I'll say it again. I was not, I didn't come into this excited about electric propulsion. It took me a while too. I was a naysayer 5-6 years ago. I took I took a drive in a few Teslas, and that started to change my mind. And then, you start to explore what the potential is from a performance standpoint. That's really why we're into this. I mean, we're performance guys. We like to go fast. This is just a new, cool way to go fast.
So any of you naysayers, you got to experience this. And no matter how hardcore of a performance guy you are, if you don't dig this, something's wrong with you.
If you like to go fast, you'll appreciate this. Just get your butt in a seat and check it out.
I mean, it's so weird. I'm not used to something that doesn't have a power band.
It has a power band. It has a because it obviously direct drive. So these motors can spin to 18,000 RPM. And, I'll echo what Nate Stewart, our lead development engineer on this set is, while it can do that, you power from 14, 15,000 starts to taper off pretty dramatically. So we moved this one up. I think this one's got a 13 or 14,000 RPM red line, and it carries the power, the horsepower band really nicely throughout that range.
It's kind of funny. You can hear like different pumps and things coming on, but no engine, no vibration.
No, if you listen closely, you can hear a little bit of a whine from the stator in the motor. It almost has like a bit of a supercharger sound to it. There's a lot of ambient noise around us, but if you listen closely, hopefully when we pull on, mat it, and then just kind of cock your ear to the back, it sounds really cool.
Yeah, I can kind of hear that.
Yeah. I love the way they spin, and indirect drive stuff is really fun. So with our VCUs, obviously a Tesla, you would never want to do this, but let's say you're building your hot rod pickup truck and you want to do an inverted Cascadia motor coupled to a Tremec, just because you want to row gears. You can do that. You can do it. You run indirect drive with our system. What's neat is you can get the motor to idle, I guess, for lack of a better term. So you can preload the motor, and like on the Cobra Jet 1400, the Ford Performance MLE race cars drag car, that's got 4 Cascadia motors. And when those things load up at the line, it sounds really cool. It'll never replace a top fuel, but it definitely has its own kind of a sound. Can you speed up? I want to read what that bumper sticker says. There we go.
Man, this thing is awesome. So this doesn't have any kind of integrated traction control or anything?
Not yet. That's that button right there. The guys are working on the traction control models. So we've been doing some testing. That eventually will get put into the car and will get tested and validated. And then once we are comfortable with the model and the interface, we'll release that as a feature. And you've been working with us a long time. The same way we approach our software and stuff the same way we have on the internal combustion side. So AEM Cal is our VCU tuning software suite, and it's free download. Anytime we upgrade it or make a feature improvement, anything, that update will be available for download. The great thing about our software, if you're used to calibrating, is once you wrap your brain around the high voltage system, which is easier than internal combustion, you're going to really love the software. Have you looked at our software yet?
Not for these.
Okay, it's super familiar. We took the same approach, tables and 3D graphs, Windows based, very intuitive and user friendly. Comparatively, your options beyond that, really for custom tuning, to be able to do torque mapping and that kind of thing on an EV is a really expensive dedicated software suite.
Can I try matting it?
Please do. Well, you might want to wait for that truck. See how it digs in?
Mm-hmm.
Now it goes. So if you want to break it loose, then 2-foot it a little bit, preload it just a little bit, and then stab and pull.
Okay. Oops.
Nope. Brake. Now load it a little. Yeah. See, it just hooks and goes.
Yeah, it starts burning out.
Yeah, and then it'll. I guess in the ice world, they would say it pulls timing, right? It's obviously not pulling timing, but it's pulling current to reduce the wheel speed so that it grips.
Feels like it's making all the use of these tires, so you could like program it for different tires, right?
Kind of, yeah. You figure out your tractive force, and then you sort of dial into how much traction you're able to.
Feels like it's in regen right now.
It is actually. When you see that little green dial on the
yeah,
that's your regen. So whenever you let off the accelerator, that tells you what you're getting back.
That was fun.
I'm so glad you liked it, Mike. I honestly, I didn't know what to expect.
Well, you thought I was going to hate it?
I didn't know. I really didn't know. What I appreciated, like I said, was you had an open mind. You were willing to check out a different kind of hot rod and see what this EV stuff is all about. The fact that you are thinking about doing one of these is the most exciting part, because we're ready to do one with you.
Hey man, that's awesome. And there's a lot of naysayers out there, but I mean, let me tell you, I experienced it. It's fun, and it goes fast, and it's awesome as a daily. So, there's no reason not to do one.
It's awesome at the track too, man. Let's get you out and let's do some racing. Grab that Evo, man. We'll go drag racing.
All right.
All right.
Thanks a lot. Thanks for bringing it.
Thank you, man. I appreciate it.